Goedemorgen. Hope you're all doing great. We're so honored to be here, so thank you so much. And we're super excited to talk about robotics and aerial robotics with you today. But my name is Kimberly McGuire. But first I will give the word to my dear friend Ramon here to first introduce himself.
All right, thank you, Kim. Thank you, everyone. Amsterdam, am I right? Yeah, I've been working in robotics for the last 13 years, mainly in drones. I'm one of the maintainers of the PX4 and PixHawk projects. I'm also the general manager for the Dronecode Foundation that hosts both projects. And I co-lead a few open source initiatives. In between one of those are the Aerial Robotics Interest Group, which we will be talking about today, but also the Space Raid Linux initiative. I'm really passionate about autonomy, and I want to do a quick commercial break before we continue talking about drones, if you allow me, Kim. So we're working on a Space Raid Linux distribution. It's a distribution of Linux for space. It's hosted under the ELISA project. You might have noticed my awesome T-shirt. Thank you. It's a Yocto meta layer for space. We got a SIG going on. We meet monthly. So if you want to contribute to space, you get your commits in space, yes. Make sure you scan that and join us in our monthly meetings.
That's a really cool T-shirt. I would like to have one of those. But I also have a very cool T-shirt. So I actually also been in robotics in general for about 15 years. I even did my PhD in it. I'm currently independent roboticist at McGuire Robotics and also co-leading the Aerial Robotics Interest Group at ROS together with my friend Ramon. Am I also invited here by the Open 3D Foundation to speak to you here today because I'm actually quite passionate about robotic simulators. So what is a robot anyway? It has sensors that's able to take input of the environment, that feeds autonomy, that then commands the actuators that then change something in the environment that the sensors are able to detect again. So basically, sense, think, and act. But not all robots are humanoids, like this drawing right here. A little insensitive to robotics. There are actually a lot of types of robots out there, like these rovers for planetary research, underwater robot for maritime inspection.
And also vertical takeoff and landing drones for survey and inspection. Or, quadcopters for recreational use, like a selfie drone. But, quadcopters can also be used for swarms, for a drone light show. We actually had one in Open Source Summit North America in Austin. Because open source and drones, it's a good match.
So today we're going to tell you a short story about robotics. About a made-up story, but it's about an intern that could. So meet Mary. She has about a couple of years of software development experience already, but she really loves open source. We all do here. And also robotics. She really thinks it's awesome. And she's super excited because she just started an internship.
All right, so she started an internship at a warehouse company. Imagine a company that ships thousands of products a day. So they have tons of shelves in a warehouse. They have a huge problem with inventory. It goes missing. So a year, they can lose millions of dollars. So
Mary proposes an idea. Pretty bold for an intern, first meeting in, but she just raises her hand and how about we automate the inventory scanning with drones?
That's pretty bold.
Yeah. But the team and the boss were immediately in, and the boss was like, I actually saw a really cool video about that lately. Let me forward that to you.
All right, let's see the video.
I've never seen this guy before in my life. So sensationalism aside, the crazy drone guy kind of validates Mary's assumptions.
Yeah, so Mary actually knows the basics of autonomy. So Mary knows that she needs to do actuator control real-time. So she's going to pair an RTOS with a non-real-time operating system for the high-level autonomy. For the real-time, though, she's going to be using the PX4 autopilot. the PX4 autopilot runs on top of an RTOS. It runs fully parallelized and thread safe. It's a stable interface to ROS thanks to its DDS-like middleware. It has great hardware support, is designed with safety in mind, supports multiple drone types, and is hosted by the Dronecode Foundation. And it's been around for more than 14 years, has a BSD3 license and a neutral governance. So it's a perfect choice for Mary.
You actually mentioned ROS. I'm not sure if everybody in the audience know that, but that actually stands for the Robotic Operating System. It's not a real operating system, but it's a mature robotics ecosystem that has also been around for years and has a very modular distributed design, being adopted by many in academia and industry, and it allows developers to reuse existing robotic autonomy packages for all kinds of different robots. Also drones.
Specifically, it's also drones. So, all right, Mary has chosen PX4 and ROS 2. So how does she actually take the code that she's going to build in the computer to a drone? So Mary picks the PX4 Autonomy Developer Kit. It's a drone designed by Model AI in partnership with Dronecode to have a development drone for PX4 developers. This is specifically created for GPS and night environments, which is kind of like what is going on in the warehouse. You know, in a warehouse, you don't really have a GPS or not strong GPS signals. You need to rely on other sensors. Luckily, this drone has a high 4K camera resolution sensor. So,
yeah, that's actually quite handy because there is this great open source project called OpenCV, which has been a staple library for years for computer vision and AI, and it has like thousands of algorithms that Mary could use potentially also for scanning all of these packages in the warehouse. Seems like the obvious choice.
It seems like a good match, Kim.
Exactly.
All right, so we got basically OpenCV that is going to be scanning the packages in the warehouse. We got ROS that is going to be handling the high-level autonomy. We got PX4 handling the real-time system in a drone. I think Mary has a good stack.
Exactly. So perhaps it's time to go a bit back to our software development backgrounds. You guys all know the DevOps cycle, right?
You do it. You do know it, right?
You must know. So if that's applicable for software engineering, it must be applicable to robotics, right?
I think it will work out. Let's see how it works out. All right, so Mary starts with a basic plan. So she knows that the drone needs to take off from the ground and then go all the way up to the top of the shelf and scan it from right to left. She measures the house, she measures the packages, and I think she figures out where the drone needs to take off and how to scan this now. So she has a flight plan.
Of course, the drone will not do that automatically. You have to write the code. So you have to program into logic. Mary has to do that as well. Writes the unit tests, of course, also like the continuous integration to make sure that it catches any of the build issues in time. Yeah, it seems like nothing can stop her, right?
All right, well, let's see if that's true. So let's review the plan again. She developed a flight plan. She coded the autonomy. She tested everything in CI. I think she's ready to do her first flight test. You guys want to see a drone flying? Yes?
Yeah.
All right. Tex, can we please load the video from the drone?
Yes.
All
Are
right.
you ready?
Ready? 3, 2, 1. Hello?
Guys?
Kim, I think this is a source problem. I think the drone's not working.
Really?
Yep. Can you see what happened?
The demo effect. Yeah, it seems that it's clear what happened. So somebody doesn't have a very good feeling for direction and actually went right instead of, or actually left instead of right. Like, it seems that somebody has done the coding a little bit wrong. It was not supposed to happen because actually left there's a wall. So yeah. Wall versus drone, who will win? Guess what? The wall. So Mary Colleagues actually has a tip for Mary. Hey, use this chatbot, use this AI to debug your problem. So she inputs the logs and asks, like, what went wrong? Why did my drone crash? What's the exact reason? And it had this to say.
All right. obviously propellers, like taking off the propellers is not a great solution. Luckily, it knows how to pull the drone's logs out of it and then actually parse them. So she generates graphs to actually try to understand what happened. After inspecting the graphs and all the flight log data, like Mary finds out what happened. Like it's staring right at her. She made the wrong assumptions. One of the sensors was rotated in the wrong direction. But like Kim, how could have Mary foreseen this? Like, what did she miss here?
Yeah, I think she could have used simulation first. Robotic simulation, that's practically you're making a game for the robot. So you make in virtual environments where you can simulate or recreate the environment that the drone or the robot is supposed to operate in. And it has physics engines to simulate at least like all the interaction that the robot has with the environment, rendering engines to also simulate the sensor inputs. And it's practically like a very crucial tool for robotic development. Like I use it all the time.
Is there an open source solution for simulation?
There is. O3DE, that stands for the Open 3D Engine. And it's actually being maintained by the Open 3D Foundation, which is also part of the Linux Foundation, actually. So this video right here, it's actually not a real warehouse. It's actually from the simulator itself. So it has very high rendering fidelity. It is also based on a game engine that has been used in AAA games. But it also now also has great robotics and ROS support. And they're definitely growing. Like they had 70,000 downloads this year, a very big increase compared to last year. So Mary's colleagues give her the floor plan of the warehouse so she's able to model all of the shelves, all of the boxes with the barcodes. And she uses O3DE to do that and making the photo realistic so that she can have a virtual robot, a virtual drone, be able to take off safely within the simulator itself.
So she can crash in the simulator.
Exactly.
Okay.
That's a little, less dangerous.
All right. So now that she has a simulation, Mary goes over her plan again. So she's got the flight plan, which is the same. She fixed the code issues, and now she added simulation into the workflow. What is missing? I think we're ready.
Yeah,
I don't think we want more accidents here. So let's make sure everything's working.
Yeah, let's double check, triple check.
All right, let me call for technical support. Folks, are you guys ready for loading the video? I think they're ready.
All right.
You guys want to see a drone flying again? Yes. All right, let's go. Yes, I think this is success, Kim.
Yeah, it seems that it's now actually working.
So basically what you have on screen here is a drone scanning inventory in a real warehouse. I know Mary's story is made up, but this video isn't. This is actually provided by one of the Dronecode companies. So they actually help companies achieve up to 99% inventory accuracy. In this example, it was up from 80%. 20x faster cycle counting when you do it real time, up to 2 times a day, versus doing it manually every 3 to 4 weeks. So it's like a 10x labor increase, and they're saving their customers millions of dollars a year in recovered lost inventory. And yeah, if it sounds real, it's because it is. It's a company called Robotics out of Silicon Valley. They're using open source to achieve this.
So that seems like a success, right?
Yeah, I think Mary nailed it.
Yeah. And actually, Mary's story is not a real one, but her Stellar Fractal story is made possible by all of these great open source projects. So all of these open source projects are being maintained by these umbrella organizations, and we also have them, and also thousands of contributors to thank for. But we have all been in Mary's shoes as roboticists, right? So like, it's not a real story, but it's definitely based on experience. Robotics is full of moments like this, like a lot of projects, a lot of information that you have to kind of dig through and see which of the projects are actually suitable for your application.
So we sort of decided to do something about it, because in open source, it's really easy to just complain about things, right? So we started the Aerial Robotics Interest Group in 2022 at Roscon in Japan, actually, in Kyoto, in the Roscon 2022. And we have helped many developers through their aerial robotics journey. How? Well, we host meetups like this one. This is the first one. We had 20 people in Japan. This is where we actually first started the group. Like a day before we actually had the meetup, we called everyone, and they showed up.
Yeah, we were very...
So fast forward to 2024. We had more than 100 members of our interest group. This is Roscon in Odense.
Yeah, and it's now, I guess the yearly meetup is now a tradition, right?
It is a tradition.
Yeah, and now it is that all of these people also helped us as well with something that we call the Air Robotic Landscape, which is a website where we can host a lot of these great projects and also tips and tricks and educational resources so that people can get started in air robotics much easier. So that we can change this ball of information to something that's a little bit more structured and refined, so that Mary doesn't have to rely on hyped videos.
All right, so if you want to check out the aerial robotics landscape, you can scan that code right there. We know that robotics can be hard, but it's easier if we work together.
And of course, we're going to have yet another aerial robotics meetup at the next Roscon, which is going to be in October in Singapore. And there's also going to be a one-day, full-day aerial robotics workshop at the same conference about PX4 and ROS. And after that, if you still want more.
And if you really want to deep dive into aerial robotics, we have the PX4 Developer Summit happening next to KubeCon in Atlanta in November 10. So I encourage everyone to scan that to check out the content for the conference.
And we can also continue the conversation today. Like our dear friend Matt, who also gave me this really nice t-shirt from Weekly Robotics, is going to have a great talk about robotics at 2 p.m. And both Ramon and I are also going to be attending a couple of sessions here, so make sure to mark these on your calendar. And we would like to thank you all for sticking around even after last night. So, yeah.
Well, thank you, everyone. We hope to see you soon, and thank you for your smiles. Bye.
Thank you.